Namaskar, welcome to Indie Global Waste Management Summit, yet another session on day two. We had an amazing inaugural session yesterday with participation from Ministry of Jal Shakti, Government of India, Ministry of Environment, and several other state governments, including Government of Telangana, Andhra Pradesh, Karnataka, Assam, uh, involving the pollution control boards, municipal corporations, and municipal uh, urban development secretaries and the commissioners of various municipal corporations also joined us in addition to corporates and the key waste management leaders in the ecosystem. So now we are at a very important session today. Now, the third session that would be focusing on waste to wealth, advanced recycling of public waste, e-waste, waste to energy technologies towards net zero pathways and creating a clean and green environment. And to do the honors, we have a very wonderful panel who have joined us from across the country. And from the Government of India side, we have a regional joint director from the state of, uh, from the Ministry of Environment, Forest and Climate Change, Government of India, uh, regionally located in Vijayawada. Please join me in welcoming Dr. Suresh Babu Pasupuleti.
Thank you.
Thanks for
Thank you,
joining.
Mr. Sudhir. Thank you.
We are also joined by Dr. Chila Venkata Ravishankar, who is the Associate Professor, Department of Civil Engineering, MVGR College of Engineering, Vizianagaram. He comes with an immense experience in the waste management sector. We'll get to hear from him. Welcome, VR Shankar.
Namaskar and good afternoon to one and all.
Namaskar. We are also joined by Sri Arun Lahoti, who is the General Secretary, Telangana Andhra Pradesh Plastic Manufacturers Association, who, in association with local urban bodies and civic bodies, are trying to ensure there is the plastic waste or the reuse that happens. We get to hear from them. Namaskar, Arunji. Thanks for joining us.
नमस्कार जी.
Namaskar. And we are also joined by B. Pullareddy, Deputy General Manager, Ultratech Cement Limited, Aditya Birla Group. Will be joined by them. And to do the honors, we have a wonderful moderator and speaker for this session. She is the co-founder and chief business officer with an organization named Recycle, which is doing wonderful job on ground in regards to waste management, involving and creating awareness, including the plastic waste. And we'll get to hear a lot of initiatives taken up by Recycle from Miss Ekta Narain. Welcome, Miss Ekta. Thanks for joining us. With this now, we'll be handing it over to our moderator, Miss Ekta Narain. Over to you, Ekta. Am I audible? Ekta, am I audible? Yes, we are joined by Mr. B. Pullareddy, Deputy General Manager, Ultratech Cement, Aditya Birla Group. Thank you, Mr. Pullareddy. Thanks for joining us.
Thank you. My pleasure.
So we're also there. There seems to be a technical hitch. Ms. Ekta Narain, who joined us. So just to give you an idea, meanwhile our moderator of the session joins us. As mentioned, advanced recycling of plastic waste, e-waste, waste to energy technologies, and towards net zero pathways and creating clean Creating a clean and green environment will be the key focus area of this session. And we have the Government of India representation, Dr. Suresh Babu, who would be talking about putting forward the policies and the initiatives being taken up at the regional level and also at the national level by the Ministry of Environment, Forest and Climate Change. And from the academia side, we have Mr. V.R. Sankar Chila. And we would like to hear from you the kind of collaborations that are happening.
Unable to hear.
Yes, yes, yes. And from the industry side, we have Mr. Pullareddy, how they are using waste as a source of energy. And Arun Lahoti is is representing the Plastic Manufacturers Association, which is plastic, which is considered as one of the waste plaguing the kind of initiative they are taking. Um, so we'll just wait for Ekta Naren.
Unable to hear, Mr. Sudhir.
Am I audible to you all? Mr. Shankar, am I audible?
Yes, yes, you are audible, sir.
Okay, okay. Okay, meanwhile, by the time Ekta reconnects us, and I would like to take the first perspective from our representative representing the government, Ministry of Environment, Forest and Climate Change, Dr. Suresh Babu. Sir, your initial remarks on these lines and the kind of policies that are in place and the kind of work that we get to see on this line of waste to wealth. Over to you, sir.
Yeah, namaskar to all the eminent speakers and all the participants and viewers from the various parts of the India, and a very good afternoon to all. Today's topic is advanced recycling of plastic waste, e-waste, and second point is waste energy technologies. Third point is towards net zero pathways and creating a clean and green environment. Coming to the plastic and e-waste management point, the Government of India, Ministry of Environment, Forest and Climate Change, in the year 2002 made two notifications and in the form of plastic waste management rules to 2022. In the month of January 2022, and e-waste management rules in 2022 in the month of November 2022. So according to these management rules, so as per the notification, Government of India MOFCC directed declared some guidelines to the state government and to the producers who is producing the plastic waste management, plastic waste as plastic as a material in their processes. So in the e-waste management also, the guidelines for the proper manufacturing of the batteries and batteries, whereas another battery waste management rules also issued, guidelines issued nowadays. Now these e-vehicles are coming up, emerging technology is coming up and using by various in industries, car manufacturing industries, and it is appropriate to issue the guidelines for the battery manufacturing and battery disposal and the recycling of batteries at various levels of the process. So various guidelines were issued to the state government and to the producers also, and at the end the recyclers also. So it given the responsibilities to the state government to look after and to maintain the proper management of these at a local level and at the state level. So these are the from the plastic and e-waste management rules. Coming to the waste and energy technologies. So waste can be divided into three types. Uh, can be three types: solid and solid, liquid, and gaseous waste. Uh, So Mr. Sudhi, can I give my complete points upon these points? So, yeah, just I will give the overview of the, yeah.
Yeah, yeah.
So coming to the waste to energy technologies, waste can be divided into 3 points. One is the solid waste, liquid waste, and gaseous waste. Coming to the solid waste, majority of the waste is from the municipal solid waste. So whereas industrial solid waste can be segregated at their industry level. Only one type of the solid waste is coming, more or less the quality and quantity will be more or less the same at the source level itself. Coming to the municipal solid waste, the waste is can be divided into two types. So one is biodegradable waste, and the second one is the non biodegradable waste. In the biodegradable waste, there are domestic methods and community higher community levels where these where this waste, where this domestic waste can be segregated and can be treated and converted into wealth product like a compost at the domestic level, whereas at the highest community level, like bigger community apartment systems, that can be converted into domestic compost by using mechanical methods. Whereas the total municipal solid waste at urban level, the conversion of waste to wealth technologies, major, if we come to the non recyclable waste or non biodegradable waste, these can be used at industry level for conversion of waste to energy technologies. There are a few technologies like biomethanation, incineration, gasification, and pyrolysis level. These are these are the four main technology can be used in from used can be used for conversion of waste into energy. Can be generated into gaseous forms or energy in the form of electricity or other solid waste or value added products. By using these, we can reduce the fossil fuels, we can reduce the waste, and we can reduce the waste management waste we can use the waste to the value added products. Why these but since 1987, India started in the first plant started in the New Delhi for the conversion of waste into energy. But till to date, these waste technologies are not that much efficient, or not promising not promising technologies for value added products. So there are few points to I wanted to highlight. First point is the quantity or quality of the waste which is available at the surrounding local level for conversion of for conversion of technology, and the inert content in the waste, the inert content which is not added to the calorific value for the processes. These cannot this is like this is will be as a inert material and cannot be used in the conversion of the energy, and it will reduce the efficiency of the plant also. And the low calorific value because of moisture present in that waste, and which cannot be removed easily, and which is very tedious to remove, and which will reduce the efficiency of the unit also. And high cost of production, because these waste to be collected and transportation, the manpower involved in the process, which result in the high cost of production per unit or per quantum of the energy we are getting from the process. These are the key factors which is to be look into the to look into for improvement of the process efficiency, and which can be converted into waste, from waste to energy. Then these technologies will be fruitful at the end for local and solid waste management this process. So for this, at the Ministry of Environment, Forest and Climate Change, at the higher community level, we are imposing strict conditions that every higher community areas like big apartments which are having more than hundreds and thousands of families, they have to install a biodegradable compost for the conversion of organic material to compost, and which can be used for their plantation purpose, which can be used for other value added products in their area. Whereas these technologies for waste to energy plants at a higher quantum level, so where ministry is also encouraging for installation and commissioning of these plants. Andhra Pradesh itself having 23.16 megawatt plants, and which are, if you are under commissioning stage, are in the installation phase also. And coming to the liquid waste processes, so there are a few processes which can be used for conversion of liquid waste into value added products like energy technologies. So liquid waste contains of higher organic content by biomethanation, biohydrogenation, and ethanol production and other value added products. By anaerobic technologies, we can convert the organic matter present in the wastewater to these direct producing direct producing methods. We can get the biomethane or biohydrogen or ethanol or other value added products. But the problem is with the these bio processes, the reaction is a bit slow reactions and involving high influencing parameter which need to be controlled in the processes for improvement of its efficiency. And whereas the availability of quantum in Andhra Pradesh itself, there are number of number of chemical industries and bulk drug units and distilleries also, which are producing high amounts of the high organic content present in the wastewater, which are presently being treated by the anaerobic digestion methods. But if we convert these technologies with the efficient anaerobic technologies, then we can produce the biomethane, biohydrogen, and other ethanol and other value-added products. Coming to the biomethane and biohydrogen, methane is a greenhouse gas, and which is which by producing methane, we can convert the process into biohydrogen. Now, in January 2023, the government of India by MNRE, Ministry of New and Renewable Energy, started a national green hydrogen mission, which targeted for 5 million metric tons of green hydrogen by 2030. By using these biohydrogen technologies, for conversion of these readily available organic rich wastewater into hydrogen and other processes, then we can convert these wastewater into the promising energy producing technologies. Whereas coming to the gas waste minister already imposed, and being number of industries being followed, the the heat rich gases coming from the processes, which can be converted into electricity by the waste heat recovery boilers, which can trap the heat energy from the gases into the electricity by boiler technologies. So these already being implemented and being implemented. I hope, if I'm not wrong, most of the 100% of the industry which are generating the waste heat gases, by installing WHR waste heat recovery boilers, they are converting waste gases into the electricity. Uh, so at the end, all the reactions will end with the CO2 generation process, CO2 generation, carbon dioxide generation. Now technologies are available at the laboratory scale. Many eminent scientists are working for conversion of laboratory scale into the industrial scale level, where carbon dioxide can be used directly in the processes that can be converted into value added products like a small like acetic acid, butyric acid, and some other small chain acids by using bioelectrochemical systems and other bio products, which can be converted these carbon dioxide into the value added product. So these technologies are required most scientific inputs for conversion of waste into technologies by improving their efficiency. Because so for example, if you take the hydrogen electrolysis process is there, which water can be converted into hydrogen by using electrolysis process, but at the end energy input is required. Whereas so energy input is required, but at the end the net energy will be minimized. Whereas in the bio process, there are a few points to be noted. Whereas bioreactions to be improved, their rate of reaction and parameter which are influencing from outside, these are to be noted for noted and to be work to be done for improving their efficiency. So the majority of scientists are working. I hope if we consider all these points, then these technologies can be improved for improvement of their efficiency. Then waste can be converted into value added products. I would like to request all the citizens that as I said, the segregation and the transportation is the key points for improving the efficiency of the waste to energy technology. So I request all the citizens of India that please segregate your waste at the domestic and household level itself, because if you segregate that, it will be easier to the local authorities and the industrial plant authorities also to use that waste directly into the process where the energy will be improved, and the efficiency of the process will also be improved. And for non inert non biodegradable and the other waste like glass and which are inert in processes, then they can be recycled in their own in by other processes. So by using these, we can improve the waste to energy technologies. In the domestic level also, there are a lot of domestic methods are available where the biodegradable kitchen waste can be converted into compost in the local itself, whereas by using traditional methods or traditional composting methods. Whereas, as I said, at the higher community level, ministry is imposing conditions to convert the biodegradable waste into compost by using mechanical composting machines. And by these, the local women and the local small families can be use these methods to convert the biodegradable waste into compost, and they can use this as their entrepreneurship models for waste to wealth technologies. And with this, I thank Indian Global Waste Management Summit management for giving me the opportunity. Thank you so much, Sudhir.
Yeah, thank you, Dr. Suresh Babu, sir. I had some technical glitch, and at the right moment, I just got out of the entire screen. So I would like to once again, welcome officially all of you. I thank in the Global Waste Management Virtual Summit, Mr. Sudhir Gautam and his team to conduct this program, and my hearty welcome to all the panel members. So thank you so much, Dr. Suresh. I think you've given us a lot of insights on waste to energy. Uh, that is one of the best way to manage the wet waste. And you have put on the right point, that is segregation. So we all understand that there is no silver bullet to solving, this solid waste pollution crisis. The generation quantity is so high, but I think fortunately there are many ways stakeholders can collaborate, and it will help us to get closer to our goal of advancing to circular economy. So we move to our next panel member. I would like to now invite Shri Sundar Reddy, Deputy General Manager from Ultrafast Cement Limited. Welcome, sir, to the event. And please unmute yourself. If you would like to say.
Am I audible?
Yes, you are on.
Oh, thank you. Yeah. Good afternoon, dear panel members. As well as my thanks to Indie Global Waste Management 2023 for having me here. Uh, Now coming to the talk that that we have in terms of using alternate fuels in the cement industry. Um I would just want to say, the various types of fuels that we are using now, and particularly, the challenges with respect to the same. So generally, at the cement or any energy intensive process which is involved, decarbonizing of the process is very much important and very relevant to the current context, owing to increased energy demand as well as massive operations that we have now. At at a larger scale, most of the cement plants in India are equipped to use alternate materials which are originated out of our cement plant boundary, or other than fossil fuel. And those materials, different types of materials, this could be used uh, as an alternative source of energy to cater our energy demand. So particularly with this, now some of very important segments of alternate energy or alternate fuels that we see is municipal solid waste, which in cities around the world might reach around 2.2 billion tons per year by the year 2025. And this municipal solid waste gets generated and is projected to increase to about 165 million tons, and further up to 436 million tons by 2050. That's what the estimate says. And about 75 to 80% of this municipal solid waste, they get collected, and out of this, only 20 to 28% is processed and treated. So there being a challenge, and cement plant being a user could be a solution. It ranges from around 70 to 90% in generally in major metro cities, and the segregation or the processed rate is below 50% in most of the smaller cities. And once this material comes, and as a cement plant we use it, we have challenges with respect to handling or storing of this material, because I'm talking about massive energy impact that this material is going to have. And at the same time, the volume of the material which is used by cement plants is also huge in nature. And inherently, such material should be replacing the conventional or the fossil fuel, which is coal or pet coke in most of the cement plant cases. It should also compete in quality terms in respect to moisture or the chloride level that this material gets into the system, as well as segregation and issues of size reduction. These are all particularly challenges that any cement industry faces. So this is an overview of what a cement plant does with alternate fuels particularly. And going forward, if there are any questions specifically targeted to me, I would be happy to answer. Thank you.
Yeah, thank you, Mr. Punarati. I think you've really touched upon a very, very vital point on the generation of waste, which is all estimated numbers. We don't have the accurate number, and this is a very, very large problem. But thanks to companies like you, under your mission of decarbonization, you are using alternate fuels. We surely will come back to you. This is something critical. I understand that this entire waste management system needs at its core the basics of sorting, basics of connection. There are some systemic changes that is required. So we will discuss this further, and I would like to now request Mr. V.R. Shankar Chilla, Dr. Chilla Venkata Ravi Shankar. I have his full name with me here. Professor from this college. So let me hear from you, sir. What are your views on what role
Thank you, Narain. So I'll just put up my presentation. No, is my presentation
what you
shared screen? It seems blocked the.
the access?
The browser has blocked your screen. That's what I'm getting.
Yeah. I think they will be trying. They'll be just providing you the access. Maybe you can share some thoughts while your presentation is getting
It seems it's getting uploaded.
great.
So I guess it is. You're able to see this particular one.
Not
Hello.
yet.
Not yet. Okay. Okay. No worries. I'll just go
Yeah,
with
yeah, it is visible.
Yeah, now it is visible. Yeah. Good afternoon to all the panelist members. So, welcome you all to the Indie Global Waste Management Virtual Workshop. So, we'll be discussing on the role of academia in accelerating the transition towards waste. It's not waste; it's resource systems planning. So, looking at the problem which is there in India. So, all the time in the past 10 years, when we are listening from the waste management sector, I look at the problem as an octopus problem. So, where the head becomes the critical situation of the India that is present over there, and there are n number of challenges that are located over here. But what is just behind this particular challenges is we have to get right with our waste characterization. So India, if you go back to 1800 century and 1900 century, it's the organic waste used to be the maximum content. As you shift on, there is an upsurge in the plastics. So slowly in our olden days, there are n number of methodologies that our great grandparents have recycled this particular waste into a resource. So slowly, when the plastic upsurge has come into the picture and the characterization of the waste is changing over the decades, it becomes very, very, very important for us to critically understand what exactly we have to diagnose with the waste. So we have to get our BP, all the clinical tests of the waste very right. That's where the waste characterization is very, very important. Next, coming to the systems approach, that what we have to look in from the setup that is there in an Indian scenario. So India is a very big country with 29 states and everything. We come up with a single shot solution. So where the ministry gives us a set of rules and everyone has to follow, which is a top-down approach. Whereas you see in a European context, 27 countries, which are unions, which are there, each individually they develop their rules and regulations, which is a bottom to top. So diagnosing a waste with the regional characterizations that are available, developing a global plus local level solutions, taking approvals from the ministries, from all the ministries or the uplines where you get the approvals, could be one critical solution for us to implement very, 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 very effective waste to wealth systems. So then what actually as a academia we are playing a role, what combination that we need to get, because in this particular panel we can see industrialists, governmentalists, startup people, a lot of people are working together. But are we getting the binding solution where we'll become and create a huge amount of potential for clearing our octopus head? All the 8 legs or 9 legs which are there for the octopus has to come onto the picture. And from the academia side, there is a huge amount of research collaborations that have to be developed, and then technical expertises are available, innovation hubs and capacity buildings are being made. So we are moving on in that particular direction. But are we getting the necessary funding? Are we getting the things right? So this has to be questioned again and again, again and again. Because when we critically do our financial planning, we have to do our base work and groundwork very, very clearly. So as an academia, specifically from our lab, what exactly we are trying to do is we are looking from a resource management point of view, where waste characterization of Indian cities are being taken care. So we critically diagnose that particular one, then understand what are the treatment technologies that can be provided, do a sustainability analysis. So based on the sustainability analysis, we can come up with which is economically viable, which is socially acceptable and environmentally sound. So then we move on to critically developing frameworks, education to the from school level to the stakeholder level, capacity building, and critically from the academia side, we come up with Mary Life, which has been introduced to change the lifestyles and everything. So nudging is the component which we are trying to do. So in a whole perspective, when I'm trying to put, it's not a simple point that we are moving on, but because India has started its journey in the year 1955 with Ministry of Agriculture developing up composting units, and which has taken a very, very serious turn in the year 1986 and slowly moved on to the solid waste. And from 2016 onwards, with the new rules which are being implemented, the urban local bodies are trying to shape their complete priorities into waste management sector. Nowadays, we can see our investigations and evidence-based systems have shown that particular one. But we are the young brothers compared to America, which has started its waste management in the year 1880s, and slowly now the stage that what you see is almost 150 plus years of hard work that is there. So India, which is a forefront runner with a huge amount of think tanks, huge amount of human resources, certainly by 2040 we have to strategize local level strategies and use all our local resources, the lessons that has been learned from each and every city that is available with us, and interconnect with all the startup people, companies and industries. And above all that, academicians has to be part into the particular in monitoring the systems, evaluating the systems, designing different technologies. Thank you.
Yeah, thank you so much, Dr. Chela. I think you have really touched on very sensitive point on behavior change. I think every individual needs to be part of it, and all this happens only when somebody is aware about it. So today, although there's a lot of work which startups or the government and various organizations or institutions are doing, but still it's not sufficient because we need participation of every individual, and every individual needs to be part of this. For that, some behavior change, lifestyle change, all these things are very critical. And I think the fundamental on segregation, etc., is also very important. And very rightly you have said that there is no tailor-made solution. India is a combination of each country, like one state is equal to one country of Europe, very rightly said. We all, and waste characterization, very critical point. I think we need to really look into it. But broadly, we know that there have been certain categories which are already defined, especially in the most problematic area of plastic, which is everybody, we are all fighting. Certain categories have been evolved. But what I worry about is that there are new categories adding up now, biodegradable, etc. That's, I think, I'd like to hear some thoughts later from each one of you on this. But before that, I would like to move to our next panel member, Shri Arun Lahoti. He is General Secretary, Telangana and Andhra Pradesh Plastic Manufacturing Association. I think this industry has given us a very useful product, and I would like to now hear from Mr. Arun on the waste management part of it.
Good evening to all. I'm audible.
Yes, you are.
Hello to everyone connected here. I would like to take this opportunity to discuss the important topic of advanced recycling of plastic waste and e-waste. Here, as a representative of the industry, which is the cause, the reason, and the solution for the said topic, I wish to share valuable information on the given subject. It's crucial to note that my perspective, as well as industries, may be somewhat limited and more commerce focused. In recent years, the immense growth in technology had led to a significant surge in the production of plastic waste and electronic e-waste. As a result, there is an urgent need for advanced recycling methods to tackle the environment challenges posed by this type of waste. Fortunately, groundbreaking achievements in the recycling industry are paving the way for more effective and efficient recycling of plastic waste and e-waste. Plastic waste, especially single-use plastic, has become global concern due to its determinal impact on the environment. Traditional recycling methods such as mechanical recycling, which involves melting of plastic and reshaping it into new products, have their limitations. These methods can only be applied on specific type of plastics and often result in downgrade quality merchandise. Additionally, the recycling process can be energy intensive, further depleting valuable resources. To combat these limitations, the development of advanced recycling technologies such as chemical recycling has gained significant attention. Chemical recycling refers to the process of breaking down plastic waste into its basic building blocks or feedstock, which can then be used to create new plastic products. This method not only allows a wider range of plastic to be recycled, including mixed and contaminated plastics, but also has the potential to produce high quality recycled materials. One promising form of chemical recycling is depolymerization, which involves breaking down the molecular structure of plastic waste into its constituent monomers. These monomers can then be used to create new plastic products that are identical in quality to the original material. This approach offers a game changing solution as it enables the recycling of plastics that were previously considered non recyclable due to their complex composition. Similarly, e waste recycling has also seen advancements in the years. Electronics contain valuable materials, as you know, such as gold, silver, copper, palladium, which are often discarded when electronic devices reach to their end life. Traditional methods of e-waste recycling, such as manual dismantling and segregation, have proven to be inefficient and labor intensive. However, innovative techniques like hydrometallurgical processes and biotechnological approaches has emerged as promising solutions for e-waste recycling. Hydrometallurgical processes involve extracting valuable metals from electronic waste using chemical methods, while biotechnological approaches utilize microorganisms to recover metals from e-waste. These methods not only enhance the recovery of valuable materials but also reduce the environmental impact associated with traditional recycling techniques. Moreover, it is encouraging that several governments and other organizations worldwide are recognizing the importance of advancing in recycling technologies for plastic e waste. The commercial industry is relying on researching community for innovative solutions in this area. The widespread adoption of technology by established industries helps to popularize and make it useful for its intended purpose. Therefore, it can't be concluded that in an industry our perspective is limited, but we commit to embracing any advances in recycling to ensure the sustainability of the trade. Thanks for your patient hearing. Thank you.
Thank you, Mr. Arun. I think this is very critical. Recycling industry is one of the major stakeholders in the entire ecosystem, who are actually helping manage the materials. But a question is that if, you rightly said, what recycling, whether recycling is happening or not, it's actually downcycling. For me, recycling is when a bottle is converted to bottle, or when the precious metals are extracted from the electronic waste. So I'm sure we need a lot of new technologies. Some of them have come, and further we expect more technologies to enter. In this context, I think EPR also has been one of the enablers, because for any activity, the first fundamental point is collection, and I think EPR has enabled a lot of collection. So, Dr. Suresh Babu, I would like to hear from you your thoughts on the initiatives that the government has taken to make India circular, especially around the two predominant categories of plastic and waste.
Yeah, coming to the plastic, government of India along with the state government also banning the single, especially the single-use plastic, because plastic came into our life way back 150 or 100 years back in 1957, I guess. So from that point onwards, we are addicted with the plastic, I can say. So because in day-to-day life, from the toothbrush to the alarm in the night, so we use a lot of plastic materials in our day-to-day life. So replacing the entire plastic is not feasible, first point. And the entire plastic is not harmful at the moment. So at the moment, single plastic is the very harmful to the environment. And waste in the form of waste handling also, plastic is cannot be disposed as like that. And decomposition in the nature mother earth, it will take hundreds to millions of years. So replacing today single use plastic handling is the tedious is the most important point to be discussed. First of all, in my view, single-use plastic is being banned in many state governments, and the central government also imposing them where repeated directions to the state government to those stop the manufacturing of single-use plastic, especially the polyethylene, which are less than 50 microns of size thickness. So by that, single-use plastic can be banned, and these has to be replaced with the natural decomposed materials, like naturally available material, I can say, like from the nowadays these banana crop waste can be converted into useful utensils, which can be replace the single use plastics, like plastic plates and plastic culturally like spoons and other things, which can be replaced by the naturally available resources. And paper straws and every other paper cellulosic material can be replaced the single-use plastics. At the other side of the table, citizens of the state government and local bodies also, they have to think about the use of naturally available material for replacing of these single-use plastic materials, which are readily available, and a bit lower cost citizen will attach to the plastic material because of their cost effectiveness and easily availability. Uh, whereas the alternative materials are a bit costlier than the present available this. Uh, the state governments and local bodies also giving their advertisements and educating the people in various forms, like advertisements and day-to-day coming to the garbage collection people, also educating them to how to replace the single-use plastic materials. Other side of the table, the citizens also to be make their efforts to minimize the and to avoid the single-use plastic material. So by this only we can achieve from the both ends. We have to see from the citizens point of view and from the state government of point of view also. State government also should encourage the naturally available processing units. It should give the intensive subsidies for encourage the especially women in the form of women empowerment. These can be produced at the local level also, village level also. So state government also should take the initiative to go into the village level also, to the small village level also, how to use their local available natural crops, like crops material can be converted into materials that can be replaced the single use plastics, so that. And other side, the citizens also should take the initiative to not to use the single-use plastic. It might if not available the material, take own bags which are used from the cloth, being manufactured from the cloth or jute bags. So by this way only we can achieve the 100% ban of single-use plastic, I would say.
Yeah, thank you, Dr. Suresh. I agree. I think there is one point which all of us should keep in mind is that there's, alternate material. That is because every material has got some consequences. Again, you use paper, that you're cutting the trees. So we need to be, very very cognizant of that impact as well. I personally feel plastic is a wonder material. We should really learn to manage this material, and awareness, etc., is very very critical. While yes, there are.
I would like to add one point in this point. I would like to generally use this statement in every public forum. Nature has a beautiful concept that nature will take whatever it gives. If nature doesn't give anything, it will not take. So if plastic is not given by the nature, then nature doesn't take. So at the end, we use any material that should we think of that whether it given by the nature or it is a man-made. Then their majority of the problem will be solved. Thank you.
Absolutely. I think that will be the ideal situation. I wish we reach that stage, but it looks very difficult. We have become used to the conveniences around us so much that I don't know how man will change his habits fully. But yes, I'm sure there will be a lot of behavior change. And we also see that there is a certain segment of plastics which are not recyclable, and that's actually creating a lot of problem. Thanks to cement companies, I think they're using that as an alternate fuel, and at least currently that looks like one of the best way to manage them. So, Mr. Pulla Reddy, I would like to hear from you. You mentioned that the brands are investing. I mean, cement brands. I mean, your brand has invested a lot in co-processing and reducing the consumption of coal. That's towards decarbonization. So, is the impact from these alternate fuel raw material, is it achieving its result? I also would like to know, is supply chain a problem for you, because there's a lot of material still there. Why it's not being consumed?
Yeah. I think, yeah, to answer the question, yes. Is it, is the impact serving the purpose, or kind of thing? Yes. See, as a as a very energy intensive industry, whether it be cement production or steel, or the power plant by itself, which produces power, all these are very energy intensive processes. And the moment I said energy intensive, amount of the fuel that we intake is also very huge. So definitely, yeah, the little that we do for co-processing, although which is quite randomly recognized as thermal substitution rate, even if it ranges somewhere around 10 to 15% all across in India, 10 to 15% substitution of the overall fuel. That is taking us somewhere in the journey. Yes, we agree that there's a lot to do in this sphere, particularly. But then, yeah, where the targets are also stretched, and every cement industry is making its strides to achieve the amount of impact that we're talking about, and getting maximum out of plastic or any kind of alternate fuel for that instance. coming back to Coming back to the supply chain side of it, yes,
Yeah.
when we agree to the point that 2.2 billion tons of waste get produces annually, and then the amount of scale and the operations required, particularly the whole gamut, I would say, is actually like, it's not a box, which we could not unbox or something. But then challenges with, particularly in terms of getting this material to the cement plants, because cement plants are located at a remote level. There are no easy accessibility is one of the problem. At the same time, giving the required quality to a cement plant, because as an industry we only understand about the input material and the output material. So the moment when you say, cement plants become, or rather, it is viewed as just as a dump yard where waste can be dumped and then they could use that kind of methodology doesn't work. So having said that, so one is, the remote location of the units, and the consistency in the quality is where it is playing the major role. Thank you.
Thank you. Thank you. So I have a question for you, Dr. Chella. See, companies today are using a lot of technology to, optimize their supply chain, to have some more data analytics around their optimizing operations, etc. Also to reduce waste. But what is that, that should be, what is that which is missing here, that's not being considered by the industry when it comes to generation of unwanted waste, something around that.
Yeah, it's not only the industry. It's like everywhere in the whole country, something that very critically that misses is the characterization of the waste. So specifically now we have only 6 or 8 categories of waste that what we are trying to do. But we have seen in the research that a place like Denmark has 48 categories of plastic. So, so now you have to get it right when we say the technologies are very 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 good, because there is 100 years of innovation in incineration technology. When you
Yeah.
bring an incineration technology to a country like India, what technology works, but
Yeah.
what is the feed that you are giving in? What is the conditions that you are working in? And
True.
specifically, industries when they start working with this particular technology varieties, so they have very huge R&D teams which are specifically working. But the externalities which are available, so the raw material that is coming in, the products that are going inside that particular one plays a very 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 critical. A very simple example that I would say is incineration. If you, it's like when you burn the waste above 1000 degrees centigrade, the furans and dioxins will not come. But the calorific value is very, very less. So the inert material comes into the picture. So automatically it falls down to 900 degree, below 900 degrees centigrade. And automatically the end which is coming, your furans and everything, which becomes a big burden either for a municipality or for a regulatory body or to an industry. So it is the way that you look at the system, the initial
Yes.
characterizations that you're doing, the diagnosis that you want to do with your waste has to be very, very critical. Because we can see, like Suresh ji has already told, pyrolysis, gasification, the 10 number of technologies are available. Are
Yes.
they suitable for the country? Is the
Yes.
investigation that we have to do. And critically, if we see India, which we have, Southern has a different waste characterization, Northern has different Central India, East India, West India. Why forget about that particular one? Within a state of, if we can see, is say urban, rural, semi-urban, all the waste characterization varies. So it is at most important for us to diagnose the waste, check which technology is viable for us, where the funding comes from, and most of the time, instead of looking at from waste management, if we say resource management, where the circular economy comes into the picture, so waste of one industry becomes the resource of the other industry. So we can see
Absolutely.
huge amount of investigations being done by industries and ministries in this particular direction. So I would say, and academia has also. So this sort of platform would bring
Yes.
every one of
Yes.
us onto one
True, true,
way.
true. Very rightly said. And I would like to ask one last question to Mr. Arun Lahoti. So, for us, the circular economy is again, recycling the material, ability of to use recycled plastic as a packaging again. But there are certain things where we know that there's a movement, but some markets are not allowing recycled content in food technology, etc. I want to know: is the industry ready to use recycled raw material?
Not got it.
I mean, today when you want to, supply the recycled content, आपने बताया कि mostly ना डाउन साइकिल हो जाता है मटेरियल. छोटे इंडस्ट्रीज में जो प्लास्टिक से जो भी दाना बनता है वो दूसरे स्मॉल एमएसएमईज लेते हैं. बट आज रिसाइकल्ड कंटेंट यूज करने के लिए वी नो दैट देयर इज अ लॉ आल्सो जहाँ पे बाइंडिंग हो गया है ब्रांड्स को कि अगले 2 साल के बाद उन्हें रिसाइकल्ड कंटेंट यूज करना है. वो पैकेजिंग में हुआ, बट और भी प्रोडक्ट्स में चाहे बेंच टेबल कुछ भी चीज़ ले लीजिए. सो क्या इंडस्ट्री रेडी है रिसाइकल्ड रॉ मटेरियल यूज करने के लिए?
यस, इंडस्ट्री रेडी है रिसाइकल रॉ मटेरियल यूज करने के लिए. ऑलरेडी कई सेक्टर्स है जहाँ पर अपने जो है रिसाइकल मटेरियल यूज होता है. जैसे नॉन एडिबल प्रोडक्ट जो होते हैं, यूटिलिटी प्रोडक्ट्स, खास करके उसके अंदर बड़े पैमाने पर बड़ी क्वांटिटी में जो है रिसाइकल मटेरियल ही इस्तेमाल होता है. जैसे सेक्टर्स हो गए फर्नीचर, डेकोरेटिव आइटम्स, और जैसे बकेट्स हो गए, टम्बलर्स हो गए, इन सब के अंदर रिसाइकल मटेरियल इस्तेमाल होकर के इस सर्कुलर इकोनॉमी के अंदर आ रहा है.
ओके, ऑलराइट,
और
थैंक यू सो मच.
सबसे बड़ी बात, इसको जो है अपने अगर गवर्नमेंट कंपलसरी कर दे बिटुमिन के अंदर ऐड करके, तो हर तरह का मिक्स्ड प्लास्टिक वेस्ट वो जो है बिटुमिन में पिघल करके रोड्स बनाने के लिए काम में आएगा. और इंडिया में जो है अपने काफ़ी इतना बड़ा इंफ्रास्ट्रक्चर है रोडवेज का, वहाँ पर इस्तेमाल करने से most of the problem can be solved.
Yes, thank you so much. I think we have really touched on very critical points today. We have the topic is waste management, but as rightly we have spoken in this discussion that it's a resource. We also believe it's a resource because we don't have the knowledge, so we just call it waste. Waste of somebody is resource to someone. I think this mindset will change shortly. The problem is very big. In fact, it's a global problem, and we cannot fight this problem with old models. We need innovations and we need collaboration. Thanks for bringing a lot of insights to this discussion. I'm sure we'll take it forward. Sudhir has to, with all his connects, he has to bring some of those, connect, the pushed for the right actions. And I also believe technology is a backbone because it brings innovation, it brings collaboration, and we have to come together and use an advanced approach to solve this problem. I thank each one of you for your insights and for your time. And Sudhir, thank you so much for bringing this most important topic on the panel today. We need to have a lot of discussions before we get into a very, very difficult situation in future. Let's
Yes.
do the right actions and save our planet Earth. Thank you very much for all your time.
You very much, Ekta. As you rightly mentioned, our perspective needs to change. I would like to mention one line mentioned about by Archana Verma, who's the senior bureaucrat with Ministry of Jal Shakti. She was like, we shouldn't use the word waste water. She was like, we should use the word use water,
Correct,
so that there
correct.
should be a respect towards these resources. I think in a similar lines, people's perspective towards waste should change slowly. Maybe we should evolve slowly that we should look at it as a resource. Maybe
Absolutely.
there will be an internal mindset change, behavioral mindset. I would like to just mention, throw some questions that have poured in from the audience. Okay, I'll just read out those questions. Maybe you can put in through our speakers here. Uh, the first question is: there is a need for change from within. Every individual needs to be aware and segregate at source. This is one. Second question: widespread adoption of technology alone will mitigate problems in recycling. Uh, Third question is: single use plastic is the biggest culprit. Can the esteemed speakers tell us where are we in India in the ban on single use plastic? Last question. There is a question for Sri Pulla Reddy, sir. Has your company touched the substitution rate of 15% rate of 15% for energy?
Okay, I think I'll leave it open for anyone to pick the question. One is a direct question. I think on behavior change segregation, maybe Dr. Chella can answer.
Yeah. So coming to the behavioral change, I'll always quote example of Japan when it comes to the behavioral change. So in many forums, many people have quoted, at first place, why do you want to keep your city dirty? Same thing applies to the solid waste. So first place, why do you want to waste your or throw your waste into a mixed bin? I can see the governments have supplied 3 bins for nice segregation. Are we really doing? So it's the education that comes from our childhood, where we have moral values, human values, which have come out. So slowly introducing small activities, not at the classroom level, but as an activity-based level, where children can go to different waste management plants, visit that particular plant, see the pitiable situations of our conditions, how they're being dumped and everything. We are very much scared to send our children to that particular locations, but somehow an activity has to be made at state level or central level that everyone should visit a plant, understand that particular how things are going on, and slowly implement it, get the things right from their home level, from an individual level. So behavioral change doesn't come overnight. It has to be a generational shift that what we have to do. So that's not an easy task. Why? Because in the waste management, we have technologies right. We have people working on that particular one right. Economy is it's like budgets are being allocated. But the shift, the economic standard variations that we have to bring, the mindset variation that we have to bring will take minimum 20 to 30 years down the line. So certainly, I can see after my retirement, my grandchildren will certainly speak a lot about recycling, which is happening. They'll be very happy to visit all the recycling plants, incineration plants, just like Copenhagen, which is a waste incineration plant. Everybody doing skiing activities, all those. Certainly, we have to see something in India very soon. So it will take minimum 30 to 40 years. Slowly, actions are on there. People are working on this particular aspect. The nudging comes into the picture. So it's every
Absolutely. Yes,
individual has to
totally
change.
agree. Totally
Right.
agree. I think on technology, I will just take a part of it, and I would like to pass the question to Dr. Suresh and maybe Arun. Mr. Arun can answer on the recycling of technology. If there's anything we would like to add more, so technology
Uh,
definitely is in every space. Yes, Mr. Sudhir. I think we are running out of time.
Another 1 minute, Ekta. Just to
All right,
one
then
second.
I think as we have to some extent discussed, maybe we can share the answer. The direct question to to Mr. Pulla Reddy, maybe you can answer
Yeah,
that.
yeah.
15%
So
component.
so as far as 15% is concerned, I think most of the plants are achieving it now. There are, when it
Right.
comes to thermal substitution rate as such, there are plants in India which are moving towards 50, 60% of thermal substitution rate. So
Yeah.
15% is quite a less number as far as thermal substitution rate is concerned. Whereas the overall energy substitution, that stands somewhere around 5 to 10%. That's thank
Yeah.
you.
Okay. Thank you. So, a small gesture. We are, as we talk, we are hosting this 2-day virtual summit. A few months, like a couple of months down the line, we will be building up a physical summit where we have a better collaboration, better association, and there would also be a networking. And we bring in all these stakeholders from the policymakers and players like Recycle, and also associations like Arun Lahoti and other key stakeholders from the government and academia and industry can join us. A small token of appreciation to our esteemed speakers who joined us, sharing their insights. Would like to present this certificate of token of appreciation. We'll start off with our speaker from representing Government of India, Dr. Suresh Babu Paspaleti. Thank you very much for joining us and sharing your insights, sir. And next up,
Okay, thank you so much.
Dr. Chila Venkata Ravishankar from the MVGR College of Engineering, Vizianagaram. Thank you very much. Uh, Also, Dr. Sri Arun Lahoti, General Secretary for Telangana AP Manufacturing Association, and Mr. Pulla Reddy, Deputy General Manager, Ultratech Cement Limited, Aditya Birla Group. Can we have the certificate of Dr. Chila Venkata Ravishankar? Dr. Chila Venkata Ravishankar. Yeah. And thank you very much, Ekta, for wonderfully moderating and bringing a holistic perspective that all of our audience and speaker, you could manage to bring that perspective in this session that was enriching.
Thank you so much. Pleasure was all mine. I had a lot of learning today. Thank you.
Thank you very much, all. As we come to the end, after this, we have one more session after which we'll be concluding this 2-day summit. Thank you very much for adding value to this summit.
Namaste.
I wish you all a great evening.
Namaste. Thank you. Thank you, everyone.
Thank you.
Thank
Thank
you,
you so
Pulla
much,
Reddy.
everyone.
Thank you.